Let's start with a riddle. What is crystal clear, 100% natural, safe to consume, however no one wants to drink it because some of it may have come from someone's toilet? The answer is purified recycled water. This irrational psychological barrier has many of us reacting with disgust to something that is completely safe. Perhaps all it needs to pass the ultimate test is a touch of branding magic, like that of energy drink marketers. In reality, different classes of recycled water can be used for many more behind-the-scenes tasks than just being served at your local cafe. Hey there, I'm James Litchens, Director of Emerging Technologies at NCS Australia. Today we'll be discussing water scarcity and how innovative digital technology and recycled water play a critical role in securing our future water supply. We'll see how an accelerated implementation of a process digital twin impacted the recycled water operations. The fact is, our planet is facing a water crisis, even in developed countries like ours. As the population grows and fresh water sources dwindle, it's critical for smart cities to optimise all available water sources. Did you know that in industries like agriculture, the government allocates a specific amount of fresh water each year, and there are significant consequences when exceeded? This is why embracing solutions like Class A recycled water is vital for our future. Melbourne Water is Australia's largest producer of Class A recycled water, which is used for a variety of non-drinking purposes. Their Western treatment plant in Werribee produces 40 billion litres of multi-classed recycled water each year. This water is in high demand as it's clean enough to wash food that will be eaten, but it's not directly drinkable. However, the production process can be prone to issues, some of which are difficult to predict, leading to supply outages with little notice to customers. This unpredictable nature of recycled water production presents challenges for three key stakeholders. Early adopting customers need a reliable supply of recycled water to plan their water usage and manage freshwater allocations effectively. To scale up operations and increase customer adoptions, producers require proof that their recycled water is a dependable source that can meet customer demands. And to make policy changes and mandate the use of recycled water, governments need evidence that water allocations can be reliably managed between fresh and recycled sources. As the technology behind recycled water production matures, we can expect to see more stable production and increased reliability. In the meantime, providing early notification to customers about potential disruptions helps demonstrate that it is possible to plan and rely on Class A recycled water for a significant portion of their overall water requirements. This will, in turn, encourage further adoption and support sustainable water management practices. This situation turns out to be the perfect candidate for digital twin technology combined with machine learning to monitor and predict future outages of Class A recycled water production. We'll walk you through the 5 stages of digital twin rollout, showcasing the NCS Twin in a Box, a digital twin accelerator. Spoiler alert, the prediction accuracy for water supply outages jumps from 0 to 80% in just 8 weeks. But the truly amazing part is what unfolds after the first accurate prediction. The NCS Accelerator builds an end-to-end, thin-slice solution. The process goes through 5 main stages. Choosing the valuable business case, then analysing historical data for common factors and identifying key signals for possible prediction. Connecting disparate data sources, establishing data feeds and IoT connectivity for real-time monitoring. Developing a user-friendly dashboard to visualise key information and provide next best actions. Discovering patterns and predicting future water supply issues. And integrating this technology to play an active role in operations and considering wider implementation at a smart city scale. With many process steps, Class A production can stop for various reasons. The accelerator's goal is to pinpoint the most significant factor in order to begin predicting it. Like a detective working an investigation, analysing key stories can crack the case. There's a business stakeholder's story, an operator engineer's story, and the data tells its own story. Stakeholders and engineers explained The production process employs ultraviolet light and chlorine disinfection, which requires very clear water. If the water has too many suspended solids or is too cloudy, known as turbidity, UV disinfection is ineffective. Wind-generated waves can significantly influence turbidity levels in the lagoons. Now, over to the data. 3 years worth of historic data totaling 1.7 gigabytes covering 700 data types was imported and then analysed to identify the key contributing factors. This diagram breaks down the feature importance, telling the story from a data science perspective. As expected, turbidity caused significant outages. Higher wind speeds played a role, also as expected. However, it was winds from a few days earlier that had more impact. The specific wind direction was even able to be narrowed down from 150 to 210 degrees. This led to developing a machine learning algorithm to predict turbidity levels up to 3 days in advance, with an accuracy of 75 to 80%, and it surfaced to a real-time view of the recycled water production process. This helps ensure timely and reliable customer communication. Operators and business stakeholders can use the dashboard to monitor and explore the status of operation. Now that we've talked about the development of the Digital Twin Accelerator, let's take a look at the actual timeline of how it performed. On October 13th, the Digital Twin build began. In late November, the pilot version of the solution was released, and just a few days later, it was already put to the test. On December 10th, the Digital Twin predicted a disruption in recycled water production 2 days ahead of time. The clock was now ticking. December 12th, right on schedule, the disruption occurred. Thanks to an accurate prediction, it allows Melbourne Water to be able to communicate the interruption to Class A recycled water customers so they can plan accordingly. But the excitement didn't end there. The Digital Twin also boldly predicted that conditions would improve the very next day, enabling production to resume. December 13th. As predicted, conditions improved and recycled water production was now back on track. So within just 8 weeks, Digital Twin technology has proven its value by precisely forecasting disruptions, streamlining communication, and boosting planning for suppliers and customers. This technology paves the way for revolutionising water management and making smarter, more eco-friendly choices in water usage. The NCS Twin-in-a-Box Digital Twin Accelerator showcases the ability to achieve tangible results within 12 weeks, compared to traditional methods taking years and costing millions. So where to from here? From a localised water utility perspective within smart cities, there are 3 key directions to consider. Experimenting with physical solutions to reduce wind, the Twin can monitor and evaluate the impacts on turbidity. It can play a more active role in operations by increasing the coverage of wider water treatment process and training next best actions. We can also evolve the Digital Twin to enable simulation capabilities, empowering users to explore and analyse the potential impact of various changes. And at a smart city scale, increased reliability in recycled water production will encourage wider adoption by various industrial and residential users. Connecting upstream and downstream components of the water network and leveraging Digital Twin technology will enable intelligent water management. Thanks for watching today's video. By producing more recycled water, consuming less fresh water, and spreading the load across multiple sources, we can ensure a sustainable and resilient water supply for our future smart cities.